Okay, so taking a look at the second part of the function notation. When we're graphing a function in the function notation, so if I have a function like f of x is equal to 3x plus 1, the values of x represent the inputs and make up the domain. The values of f of x represent the outputs and make up the range. In previous lessons, we have used y to represent the outputs in the range. We can therefore write the function f of x is equal to 3x plus 1 in xy notation as y is equal to 3x plus 1. So the value of f of x is going to be the same as the value of y. So we have our function notation form here, and we have our xy notation, or our equation in two variables. Is going to be y is equal to 3x plus 1. Still knowing that the values of the independent or the inputs are going to be on the horizontal axis, the values of the output are going to be on the vertical axis. So you can see here, when we plug it into our graphing calculator to get a rough sketch of what this looks like, then I can see that the y has been replaced with f of x. The x is still going to be the x, but we know that f of x is the same as y. And when I put 3x plus 1 in my calculator, it's going to look something like this. So, for example 2, in each case express the relation given its function notation as an equation in two variables. All we're doing is we're just converting the function notation back into two variables. It's really simple. We just need to know that f of x represents y. So I'm going to say that y is equal to 7x minus 23. G of x is going to represent my vertical as well, so I can say y is equal to t squared minus 2t plus 35. If I'm going in the opposite direction, if I want to express a function in function notation, I'm just going to replace the y with f of x is equal to 11x minus 15. Or in C, when it says the graph of the function defined by y is equal to f of x has an equation y is equal to 4 minus 3x, expressed in function notation, well, f of x is going to equal 4 minus 3x. So when it says function notation, we're looking for f of x or g of x or c of t, whatever it happens to be, whatever the variables are. If I want in two variables, then I'm just going to get rid of the bracketed part, saying that it's going to be dependent on the other one. Alright, how can I use that to solve things on a graph? Well, I have a full function shown here, where even though it's not a straight line, here it's building through, dropping down, and all of this line, all the way through it here, is my function, whatever that function happens to be. So, when it says that it wants us to solve for f of 5, that means it wants us to know what the value of the function is when x is equal to 5. Well, when x is equal to 5 here, then I can see that my function is equal to negative 2. When it says negative 2 for x, then my function has a value of 3. When it says 4 for x, then that's going to be right here, and my function has a value of negative 1. If I'm stating what these values are in ordered pairs, I'm going to have 5 and negative 2 is one point that it goes through. I'm going to have negative 2 and 3 is another point, and I'm going to have 4 and negative 1 is the last point. And I can see all those points right here, and right here. Those are the exact coordinates of those points. Now, if it's giving me the value of f of x, I'm going to take a look at my vertical and say, well, if my vertical, If my vertical is -1, then I go down to -1 here, and I can see that at -1, x is equal to 4. When it says that f of x is equal to 3, well, f of x is 3 here, and in this case, I actually have 2 perspective points that it could go through when f of x is 3. When f of x is 3, x is either equal to, the one on the left is going to be -2, and the one on the right here is going to be +2. And at the same rate, when f of x is equal to 4, this one also has 2 perspective points. There, x is going to either equal -1 or +1. Now, if I'm using the notation in the first part A to make statements about points A and B on the graph, I'm going to solve for what those points are and say that this point would be -5 and 1, and that this point is going to be 6 and -3. If I want to write it out in the same format as A, I'm going to say the function when x is equal to -5 is going to equal 1. Or the function when x is equal to 6 is going to equal -3. If I'm writing the x and the y intercepts, well, we can see that the x-intercepts happen twice. Once right here, and once over here. If I'm using the function notation, like we did in part A, then I'm going to say that for the x-intercepts, for the x-intercepts, it's going to be when f of x equals 0, then x is going to equal -6 or +3. And that's going to be my x-intercepts. For my y-intercept, we can see that it's right up on the top here. When x is equals 0, then y is equal to 5. If I'm listing the domain and the range of this, we're going to use the whole numbers that we can see. So I'm going to say, well, what is the lowest point for x? The lowest point for x is going to be -6. What is the highest point that x reaches? 7. So the domain is -6 is less than or equal to x, which is less than or equal to +7. If I want the range, the lowest point that y reaches down here is -4, and the highest point that it goes up to is +5. So I'm going to say -4 is less than or equal to f of x, which is less than or equal to 5, where f of x is equal to every real number. Okay, try some practice.